Here we have our opening screen, and I'll point out a few features that are important whenever developing host screens. First, the medium contrast ensures that our network operations center operators are not straining or becoming fatigued during their shift. Next, the use of red is limited to alarms, failed states or items potentially requiring action. We will note the host date and time is always in the upper right corner. This screen features our alarm log, which is at the bottom of every screen to ensure that alarms are recognized when they come in. Just above that you will find our standard navigation buttons, which are mirrored on every screen to ensure ease of navigation.
This opening screen outlines our various sites with a site ID number and a site name. On the left, we have an indicator as to whether our communications are turned on or off. This is important because occasionally we have sites that are offline due to scheduled maintenance and don't want our network operators opening tickets unnecessarily. To the right of our site button, we have an indicator that confirms site utility power is adequate, as well as an indicator that communications are functioning correctly. This allows us to identify power and communications issues at a large number of sites with a quick glance.
If we click on a site identification button, we will be taken to the details screen, which provides a snapshot of the site, which allow us to quickly assess whether the site is working correctly. Our site ID and name are in bright letters top and center. This site has a standby diesel generator controller with an integrated transfer switch. This is indicated by the initials GCA in the top left, and has a date and time stamp of the last communication with the site. We synchronize our controllers with the host in the data center daily, so it is possible to correlate the last communication date and time with the current host date and time in the top right corner.
Our next poll countdown timer indicates when the next poll is expected. The intervals are configured on a site-by-site basis to meet specified demand targets. If we want to expedite control operations or refresh data, we can choose to enter or leave the site. This will effectively poll the site every 10 seconds, which we can verify by monitoring the date and time of the last poll. This will continue for 90 seconds, at which time the site will automatically return to its normal polling interval. We can initiate or release in or leave of the site from this screen or from the communications screens.
Our controllers integrate an automatic transfer switch that will sense a utility line operating out of specifications, start the generator, transfer the load, and log all the data. First we will cover the basic operation, and then we will circle around to capture the metering displayed on the screen. We have a utility power indicator here, which is displayed as green when utility power is within specified parameters, and will turn red when any type of failure is sensed. This is metered at the transfer switch, and the transfer switch is actively keeping the utility power connected to the load as indicated here. In the event we had a utility power supply operating outside of normal limits, this indicator would go dark, the transfer switch would disengage the load as indicated here, and start the generator. Currently the generator indicator is grayed out as the generator is in the standby state. If the generator is running, the indicator will be yellow, to indicate an abnormal status, and red is reserved for operational failures or alarms. Once the generator starts and completes its warm-up cycle, the load would be connected to the generator.
In this case, the load is primarily a rectifier which charges a large battery bank and supplies DC power to equipment owned and operated by multiple customers. Once utility power is restored, this indicator will light again, and a timer will start to ensure the utility power has stabilized. Once the timer completes, the load will be removed from the generator and returned to the utility. This indicator will go dark and this one would illuminate, and the generator would complete its cool-down cycle before going offline. It should be noted that these controllers include a mechanical interlock that prohibits the generator from being able to backfeed the utility line.
I'll review the metering from left to right, starting with the utility total kilowatt hours today, total kilowatt hours supplied yesterday, and overall kilowatt hours since installation. On the generator side of the screen, the same values are apparent, but also includes the generator run hours and number of starts for today, yesterday, and overall total. This can be useful in determining maintenance intervals, or troubleshooting technical problems, or verifying that repairs have been successful. Under the generator, we have current values outlined in green for instantaneous kilowatt hours, amps on line 1 and line 2, voltages and frequency as well. We have included our start battery voltage, as well as our fuel level and oil pressure. These are good indicators of overall generator health, and provide good information for technicians in the event troubleshooting is required. These are also good to review on a regular basis when planning maintenance to get in front of weak generator start batteries or engines encountering low oil pressure. Being able to see today's extreme values and yesterday's is helpful in determining how service issues are developing, assessing fuel reserves during emergency operation, and verifying that previous days' repairs have been successful.
Under the utility power side of the screen, these values are mirrored for the utility line. At this site we have added a communications room temperature, generator room temperature, and UPS overall battery voltage to our analog metering. At this site we are also tracking some digital points, such as the door alarm, tower lighting top red light, rectifier failure alarm, and the HVAC circuit breaker. The indicator on the left is the current digital status, whereas the indicator on the right is the latched status. If an alarm is instantaneous, the latched indicator will set, and the host will receive the data on the next pole interval. The host will reset these latched indicators after a regular pole, and it will be ready for another trigger immediately if required. All of our digital inputs are also timed and counted, and this data is logged on each regular pole. This is particularly helpful in identifying and repairing toggling sensors and failed end devices.
We have 4 letters that indicate generator issues and are labeled as alarms, warnings, shutdown, and emergency. Warning and alarm is related to high versus high set points. Shutdown is a scenario where we would shut down the engine to prevent damage such as low oil pressure or belt failure. Emergency might be a fuel leak or something of that nature. Our controller graphic includes a primary indicator of the active mode, as well as 5 command buttons. Stop is an emergency button that will force the generator to stop immediately. Manual will place the controller in manual mode, and test will simulate a utility power failure. Auto will place the unit in standby mode, ready to start the generator in the event of a power failure. On will cause the generator to start and run. We will do a quick demonstration with no load to ensure that we do not risk taking any customers offline.
This is a good example of when to utilize the interleave command. In order for the generator controller to accept remote operational commands, we must first put the controller in manual mode. When I press the manual button, the button will turn yellow to indicate the request is queued, and will subsequently turn green when the request is sent. When it returns to black, that will mean that we have verified the request landed at site, and a regular poll will complete to update our primary indicator to verify the new status. It should also be noted that any commands sent from the Network Operations Center are logged in the alarm log, as well as the event log. Now I will select the On button, and again yellow indicates that the request is queued, and green indicates the On command is actively being sent. We should quickly see our line voltages and frequency at normal operating levels. It is apparent that the startup has impacted the start battery values, and we can see that the oil pressure is at a normal operating value. Our instantaneous kilowatt hours and amperage does not register, as we have no load on the generator currently. Now we will shut down the generator using the stop command. The indicator will go yellow, green and then black, and we should see our active mode indicate stop. Now we will place it back in auto mode. It will take some time for these commands to complete, as each communication traverses multiple layers of security. The values will take a few seconds to update, as the regular poles come in while the generator is cooling off. It is important not to issue the commands too quickly, or you can easily lose track of which ones are queued, which can cause undesired operation. Before moving on to other tasks, it is recommended to wait for the active mode indicator to update to auto. This will ensure that the generator is standing by to start in the event of abnormal utility line power is detected.